Hi guys, it's Mrs. Moss here, and we are moving into outer space and talking about the solar system today. When we look at the solar system, we look at all of the planets that are orbiting our sun. So we are going to turn to page 15 of our reference table. Hit pause, go get your reference table, and I want you to look at the bottom of the page. What you'll see is the solar system data chart. Now notice it has the sun, and it has the moon on here as well. So we're going to be concentrating today on all of the planets that are listed in between the sun and the moon. Now, anytime you need any specific type of information, this chart will tell you that. It goes how far away we are from the sun, the period of revolution or how long it takes to go around the sun, the period of rotation of that planet, the eccentricity of the orbit, which we will talk about and discuss in full detail a little later in our unit, the size of the planet, the mass of the planet, and the planet's density. So we're going to look at each one of these planets right now. Let's start with the inner planets. These planets are known as the terrestrial planets. They are Mercury, Venus, Earth, and Mars. Now, the word terrestrial means Earth-like. So when you hear extraterrestrials, terrestrial beings, extraterrestrial beings are not Earth-like beings. They're relatively small planets. They're made up of solid rock. Their densities are very high because they're made of solid rock. And they have very few moons, if any at all. So again, when we talk about the inner planets, we're talking about the planets that are closest to the sun, and they are Mercury, Venus, Earth, and Mars. Let's look at them a little more closely. Here is Mercury, named after the god, and it is the closest planet to the sun. There's only 88 days for one revolution going around the sun. Mercury has no atmosphere, and it will have large temperature ranges from 600 degrees Fahrenheit between the coldest and hottest spots. And it has visible impact craters. Now, impact craters are craters that have hit that planet, and you can see that because there is no atmosphere to wipe away those craters or cover it up with erosion of wind or water, those planets' craters will remain there, similar to the moon. Then we have Venus, again, named after a goddess. This is the sister planet to Earth because it's similar in size, density, and mass. It is the hottest planet in the solar system, believe it or not Mercury, which is the closest to the sun, but Venus is the hottest planet. And that's also because it has such a thick atmosphere that's composed of carbon dioxide, which is a greenhouse gas. Now, so this greenhouse gas actually, as it does with our atmosphere, it warms it up. Being so close to the sun and having so much carbon dioxide in its atmosphere, that's what heats up the planet. Then we have Earth. Now, Earth is the only planet with an atmosphere of free oxygen. It's not stored or bound with any other molecule. We have liquid water on our surface. There's life, and we have one moon, as you know, and our temperature can range from negative 92 degrees Fahrenheit all the way to 136 degrees Fahrenheit. Moving on, we get to Mars. Now, Mars is one of the closest planets to us, and therefore we've been able to send different robots and send different scientific tools and instruments to help us get information from Mars. This is a picture of the Martian landscape that this rover that I just showed you a picture of was able to transmit back to Earth to give us an idea of what Martian landscape is made up of. Now, Mars has a very thin atmosphere of carbon dioxide, and it's very cold temperatures. There is liquid water that may have flowed over the surface at one time, but it's not there anymore. It's home to the largest volcano in the solar system, which is called Olympus Mons. Mars has 2 moons, and it has a temperature range from negative 220 degrees Fahrenheit to 68 degrees Fahrenheit. So those are our inner planets: Mercury, Venus, Earth, and Mars. Now, the interesting thing between Mars and Earth and Jupiter, the 2 planets that distinguish the terrestrial planets and the inner planets, from the outer Jovian planets is an asteroid belt. And if you look at this diagram, you see that between Mars, which is this last orbit here, and Jupiter, look how far away Jupiter is in comparison to the inner planets being so close to one another. In between here is an asteroid belt. Now this asteroid belt, here's a picture of a simulation of some asteroids in that belt. The mass and gravity of Jupiter probably prevented these chunks of ice and rock from solidifying, coalescing together to form another planet. Notice their irregular shapes. So the asteroids are really just chunks of rock and ice that are suspended in space. So now that brings us to our Jovian planets, our planets that are after the asteroid belt. And I want you to remember Jovian planets because they're Jupiter-like planets, J for Jupiter. So these include Jupiter, Saturn, Uranus, and Neptune. They're extremely large planets. The surface of the planets are not made up of gas. The surface of these planets are made of gas. They are not solid. And they have very low densities because of this. Many, many, many moons for each of these planets as well. The first one we're going to take a look at is Jupiter. Here's some pictures of Jupiter that we've gotten from our Hubble spacecraft that is circulating our Earth and sending us amazing pictures of space. Jupiter is our largest planet in our solar system, and it takes 12 years for Jupiter to revolve around the sun once. Jupiter's made of gases, hydrogen, helium, water, nitrogen, surrounding tiny rock core. The great red spot that we've seen in many pictures is about the size of 2 planet Earths, and it's actually a very massive violent hurricane that's been raging for over 300 years. As of April 2003, almost 10 years ago, there are 60 moons that have been spotted for revolving around Jupiter. Moving on to Saturn, probably our more popular of the planets because of its notable rings. It's the second largest planet in the solar system, made up of the gases hydrogen, helium, and methane. As of 2003, 31 moons have been discovered orbiting Saturn. It has the extensive ring system that you're so familiar with, and the ring system is made of ice particles. Now, because it is so far from the sun, this is going to have a temperature of negative 312 degrees Fahrenheit. And it is Uranus, and further from Saturn. Now, if you notice this picture, this actually looks like it has some very faint rings, but it also looks like it's upside down. That's because, believe it or not, it is tilted at an angle of 98 degrees, whereas we're tilted at 23.5, so it gives us a little tilt. That's tilted at 98 degrees, so it actually looks as if it's floating in outer space, almost upside down. The bluish color of Uranus is made from the gas methane, and it has a set of very faint rings. It takes Uranus 84 years to revolve around the sun, and it has a temperature of negative 353. Now let's move on to Neptune, our last planet in our solar system, and it's also named after a god. Now this is also a blue planet, again resulting from methane gas that's released. Neptune has the great dark spot, which is a violent storm, just like Jupiter's. It has a set of very faint rings as well, and it has a total of 11 moons that have been discovered. Neptune, because it is the farthest planet, has a cold temperature of negative 370 degrees Fahrenheit. So again, this is the end of the solar system for right now, but I want to make you aware of going and using the reference table to help you understand the differences between the 2 sets of planets, the inner planets and the outer planets. What I want you to do now in your reference table, now that you've taken all of your notes, I want you to draw a line in your reference table to remind yourself where the asteroid belt is. draw it all across the reference table. Okay, and hopefully you did it in the right spot between Mars and Jupiter. I'm going to check this tomorrow, so try to get it done. Take care. Have a great day.